Hey class, Dr. Menzmer here. Today I want to give you a very brief tutorial on how to calculate canopy cover using the Gap Light Analyzer software. So first, very few things. First, this program only works on a Windows PC computer. Unfortunately, it is not compatible with Mac. So if you don't have a Windows PC, please find a friend that does to download the software. It is free. I'll put a link in the description below for where to for the website to go download it on. Secondly, kind of why would you want to calculate canopy cover as a plant ecologist? So, broadly speaking, when you're setting up an experimental design and trying to figure out what data you're going to collect, there's two broad camps. The first is biotic data. That's things that are alive. So, in the world of plant ecology, we're looking at like the actual plants of, what are the species? What's the name of the species? Percent cover, how much of it is there? Because we can go on and calculate diversity and richness and evenness and composition, things like that later. So basically, species ID and percent cover. Then that's all biotic. Then we have abiotic data, which is data about things that aren't living. So soil moisture, temperature, elevation, light availability, canopy cover, especially the focus of my dissertation looking at herbaceous plants, so like wildflowers, things that are very close down to the ground are impacted by all the leaves of the canopy trees up tall. So when you can take a photo from an herb plant's view, if you will, at your quadrat up at the canopy, that really helps to, you can do statistical tests to determine is there a significant difference between the light availability or the canopy cover or canopy openness. So canopy openness and canopy cover are basically, one is talking about how much light is there, and the other is talking about how much non-light is there, how much leaves are there. Uh, you can see how much these vary between one treatment to another. Um, so that is kind of why you might want to do it, kind of see how, be able to statistically quantify the importance of light to the growth of certain types or species of groups or species of plants. And of course, light is super important to how plants grow. So with that being said, let's get on with the show and I'll bring up Gap Light Analyzer. Okay, here we go. I've opened up the program. It looks like this. I'm going to go to the open icon and grab a photo, this GLA example photo. This is one I took as part of my doctoral work at a site in Tennessee. So here we go. Now, what's really important, the first step when you take this photo, and I will note that this was taken with a fisheye lens that gives you a little more of a 360-degree view. I will put a link down in the description below for that fisheye lens. It's compatible with many different Canon cameras. I happen to have a Canon camera, so if you want to buy that, I think it's certainly a great lens to use for this purpose. Anyway, you have the image. The important thing is to figure out where north and where south is. So, knowing that, when I went and took the photo, I placed my hiking stick in the north direction. So, it takes a little bit of forethought, but not too much hard work to figure that out. So, now I know that that's the north direction. What I'm going to do is go to configure here and register image. And you can kind of see the directions down here. It says drag mouse from north indicator to south indicator. So I'm just going to kind of take this little icon cursor thing here and go from the north, kind of what I think is probably going to be the south. And the key here is that you kind of can see this gray circle line. That's kind of where we're going to be focusing our analysis of the image. It can't be, the lines can't be off of the photograph. So they all have to be internal to the photograph. So I'd say this is probably pretty good. There we go. Then I'm going to do OK. Wait for a minute. Cue the Jeopardy theme music. Looks like it's starting to work. Okay, there we go. Now we have the registered image on the left and the working image on the right. You can think of the registered image as like a reference, and all the changes we're going to be doing will be indicated and exhibited in the working image. So now what we want to do is go to image on the bar here and then click threshold. This step basically converts every single pixel in our working image to either black, meaning it's a tree leaf that's blocking the sunlight, or white, which is meaning that it's there's no tree leaves there, there's no canopy there, and it's actual sunlight coming down to the herb layer. So you can have it all the way up to 255 pixel value. You can have it down at 99, do it a lot less. That's not really going to work well, not very ecologically meaningful. Um, even like if you do something in the middle here, like 99, you can see like all these on the kind of left-hand side, it's all white, but really that is just lighter tree leaves rather than actual sunlight. So there are different perspectives on this, but I feel that it really doesn't hurt to have as maximum the maximum number of pixels possible to give you the most accurate image possible. So I'm gonna say for our purposes, and I would certainly recommend doing maximum pixels, is looking actually pretty accurate when you're looking at from the registered image to the working image, and all the areas of white do kind of match up with the truth areas of white in the registered image. So do as much accuracy in pixels as possible. Then go ahead and click OK. Okay, now that we've done that, the last step to get can be covered. Well, maybe next to last step. Anyway, the next step is to go to calculate and run calculations. And then you want to select this canopy structure and transmitted gap light option and click calculate. Again, cue some Jeopardy theme music. So here we go. We have our summary result tables. You can see the third line down says canopy openness. So as I said, remember, canopy openness is the reverse of canopy cover. So canopy openness appears to be about maybe 1.38%. Um, so that's basically saying that of this entire image, 1.38% of it is the sunlight coming down to the herb layer in our quadrant. So to get canopy cover, all you would do is the inverse of 100 minus 1.38 to get canopy cover. So depending whether your instructor or if you're doing it your project, if you're wanting canopy openness, so or light availability versus canopy cover, that's the metric of that's the conversion. Um, yeah, so that is the tutorial on how to calculate light availability or canopy cover using hemispherical photography from Gap Light Analyzer. If you have any questions, please let me know in the comments below. I am happy to answer them. And if you have an idea for another tutorial for statistical analysis relating to plant ecology, please let me know about that. Would love to hear your ideas down in the comments below. Till then, class is dismissed. Thanks so much for watching.